Okay, so just a little bit more on experiments here. So we can have double-blind experiments. So an experiment is double-blind if neither the investigators nor the subjects know who has been assigned to the treatment. When investigators or subjects know which treatment is being given, they may tend to report results differently. Therefore, experiments should be double-blind whenever possible. So what we're trying to avoid is confirmation bias. Oops. Confirmation bias. So your confirmation bias is when you look for things that back your what you think is going to happen. So unfortunately, this can happen to investigators. They try not to, but it's kind of hard when you're invested into your whatever you're researching to not try to see effects that are not necessarily there. So an investigator or researcher, if they give a treatment and they know that, say, Bob got the treatment and Alice didn't, they're gonna every time Bob tells them something positive, they're like gonna go, oh yeah, Bob's totally doing better because they want Bob to do better. They want their treatment to work. Where if Alice said, oh yeah, she's feeling this improvement, they'd just be like, oh, okay, she's feeling some improvement, but they might not get excited about it because they're not thinking it has to do with there's no drug involved. So what's going to cause is they may get over report on things, like see things that are not really there is the problem. So to avoid that, the investigators themselves just don't know who is treated. So usually have some sort of a middle person who's going to assign the treatments, but the investigators are not going to know who got what treatment. That's not something they would know until the very end after they did all their investigating and made their reporting, then they would get all that data. So we like to do double blind if we can. Sometimes it's not always possible, and sometimes it doesn't actually really help out that much. But frequently, if we can, we like to do those double blind experiments so the investigators are not, investing into the situation because they don't know where to invest. And then we have randomized block experiments. So these are probably one of the best ways to do an experiment. So in a completely randomized experiment, there is no restriction on which subjects may be assigned which treatment. In some situations, it may be desirable to restrict the randomization a bit. So we do this in a lot of cases of like drug trials, because one of the things we said is like a lot of things can affect how how a drug behaves. There's genetic factors that will affect it. There is your sex will affect it. Your age can affect how a drug would work. So a lot of times you see this block experiment when you're talking about medical studies. So in some situations, it may be desirable to restrict the randomization a bit. This can be accomplished through randomized block experiments. So imagine the two reading programs are to be tested in a school that has children from grades 1 through 4. If children are assigned at random, there's a good possibility we'd end up with a bunch of fourth graders in one group and not so many in the other group. And since they tend to be better readers because they're a little older and had more practice, this will give that program an advantage. So what we're saying is that if I made my two groups, and maybe I had like one fourth grader here, and then I had like most of my fourth graders in this group, we expect this group's probably going to improve. We're going to see improvements or better scoring in this group. And when even if we're testing two reading programs, we don't know which one's getting which, is a chance that that group of the 4-year-olds is going to do better. And like I said, and this is not purposely trying to put fourth graders in a group, it's just you randomized it and you're going to end up with more in one group than another. It's just what happens when you randomize things. So we went so this can be avoided if by randomizing the students within each group separately. So what instead we would do is we would take everybody who's in the first grade and we would randomly assign some of the new program or program 1. And then we would assign some to program 2. And then we would do the same thing for second graders. We'd put randomly assign some to program 1 and then randomly assign some to program 2. Well, what this means is that in the end, when we get down to our complete sample, we should have even amounts of first graders, second graders, third graders, and fourth graders in each group. So then when we do the study, it should be easier if we won't bias it in one way or the other because we'll have even amounts of each grade into each group. So just as an example to kind of work on ourselves, a company wants to test the effectiveness of a new drug developed to help people quit smoking. It is believed that men struggle with quitting more than women do. So how can we construct, that was a tip on there, how can we construct a randomized block experiment to test the effectiveness of the new drug? So what we would do is we'd take our men and we would take women. So these would be my 2 blocks. And what we would do from there is that we would take and we would randomly assign some of them to the new gum, and then some of them are going to be our control group. And we're going to do the same thing with women. And what we're hoping here is that in the end, when we're looking at our 2 groups, we're looking at our treatment with the gum, and then our treatment with the our control, so the one that didn't get the treatment at all. What we're hoping to see is that 50% of the women are going to be in here, and probably 50% of the men would be in here. And then 50% of all the women would be here, and 50% of all those women would be here. So what we would end up doing, like I said, if the thing we wanted to control is a factor that we think is going to have an impact, we think men and women are going to react differently. Therefore, we want to make sure that they're evenly distributed between both groups. So we would take the men, half of them would have the new gum, half of them would be my control group. We do the same thing with the women. Half of them would have the new gum, half of them would be the control. So if we had 50 men, 25 would be here, 25 would be here. If we had 40 women, 20 would be in this group, 20 would be in this group. So we'd have a group here that would have 25 men and 20 women, 25 men and 20 women. But what's important is that they have the same proportions of men and women. So when we look at the effectiveness of this gum, we should see a difference between those groups because we've made those groups the same.